What's really happening on Venus? Scientists reveal surprising patterns.
Venus, the closest planet to Earth and often called its twin, hides its surface under a thick layer of clouds that makes it extremely difficult to observe directly.
For decades, the little information about what happens on the ground has come from older missions, such as the Soviet Venera probes, which managed to land and measure extreme conditions, temperatures above 460 degrees Celsius, crushing pressure, and weak winds near the ground. Now, recent research is beginning to shed more light on surface wind behavior, temperature variations, and dust movement, helping to prepare for future landing missions. Led by Maxence Lefèvre of the Sorbonne in France, the team used the scarce data available, such as wind speeds close to 1 meter per second recorded by Venera, to create a detailed regional model. Instead of treating the entire planet uniformly, they divided Venus into different zones: highlands, plains, tropical regions, and poles. This approach revealed unexpected and surprising patterns. One of the most interesting findings is that regional winds help stabilize temperatures in the mountains. In Venus's day-night cycle, which lasts about 117 Earth days, the ground heats up during the long day and cools at night through infrared radiation. In tropical regions, ascending, anabatic, winds arise during the day, rising up the heated slopes, and descending, katabatic, winds at night. Descending from the cold heights, at the poles, the katabatic wind flows constantly downwards. In the highlands, these descending winds compress as they descend, heating the air through adiabatic compression, a process similar to what occurs in Earth's mountains. This heating exactly compensates for the nighttime cooling, causing the temperature to vary by less than 1 Kelvin between day and night in mountainous regions. In the lowlands, without this effect, the variation reaches about 4 Kelvin.
Another surprising aspect is the transport of dust. Although winds on the surface are slow compared to those on Earth or Mars, Venus's dense atmosphere requires a lot of energy to move the particles. The model shows that these winds can lift fine sand up to 75 micrometers in certain areas, such as the Alpha Regio Plateau near the equator. About 45% of this region can be affected by dust storms that vary throughout the day, representing a real challenge for probes intending to land there. These patterns show that Venus is not a static and uniform world as previously thought. The winds act as a climate regulator on the surface, influencing temperature and dust regionally, similar to Earth's weather patterns. But under extreme conditions, the study, published in October 2025 in the Journal of Geophysical Research, Planets, is especially useful for planning future missions, such as NASA's Da Vinci, which is scheduled to land on Alpha Regio, as well as Envision and Veritas. A better understanding of these winds, thermal variations, and dust risk helps in designing more robust equipment and choosing safer landing sites. This research demonstrates how, even with limited data from decades ago, intelligent models can reveal hidden secrets of Venus, shedding some light on the hostile and fascinating environment of this neighboring planet.